we're writing this program in C with the addition of cin and cout and reference parameters from C++. So the question is, how do we do that since we're not doing it graphically? We're just using ASCII graphics. So think of this board position here where gray moved first, then red, then gray. But instead of gray and red, we're going to use X's and O's. So if you want to go log into your Bert or Ernie CS account here at UIC, you can then type in ~I102/Kaos to run the program. Instructions come up at the beginning, and now here we can see the interface. So this notion of stacking is done by actually just listing these. So the X for gray will go at the bottom, and then the O for red will go there, and then the next X will go right there. So if we actually make these moves, we'd see that in square one, we're going to place the X. And so now we can see that it's there. And then for square one again, now it's red, that is O, to move, and shows up. And then again for gray. As we continue on, I've placed debugging information in here so that you can see what happens for the redistribution. So if we have another move that goes in position 1, we see that the pieces get redistributed. So in this case, O is moving in position 1. I have a message that says there's a full stack at position 1, and I actually show what that full stack is. And the top piece is going to go first. And this is from the perspective of O, which is at the bottom. So the O is going to go off the top, which gets returned to the stack. So the number of pieces of O is going to go from 10 to 11. Then the X is going to go off to the right, then an O down, and the last X is going to go to the left. And we can see that happened. The O went off the top. This next X came to the right on the stack over here. This next O went down below. We see that down here. And this last X went off the board, so that increased the number of pieces for X back up to 11. And we see here the number of pieces for O again is also up to 11. Interesting thing, if you leave spaces between your inputs, you can actually type them all in one line. So let's say I want to fill up these spots up here. This column number 1, I want to fill up column number 2, column 4, square 1, square 2, square 4, and square 5. So I can actually type in all my pieces and just leave a space between them, and I don't have to do it one by one because it buffers my input. So I can say, let's put 3 moves in a row, alternating of course for X and O, into square 1, like that. And then in square 2, I can also have 3, and then in square 4, I can put a couple more, and square 5, I can put 3 in a row there. And so now I have my scenario of what happens with the redistributions when I have multiple ones in a row. So let's say I place for X a 1, in position 1. Here we go. And I can back up and show all the intermediate steps. Also notice that there's move numbers here. So move number 14, at that point, then I entered a 1 for X to move. And I said I had a full stack at position 1, so that needed to be redistributed. So there's the full stack at position 1. Now I'm redistributing the pieces for X at position 1. And when I do that redistribution, so notice that this top X here is going to go first. So from the perspective of X, this is going to go down below, which then I'm going to need to enter square 4 in my redistribution list. So I say full stack at position 4. And then this next X goes off here to that side. The O would go off the board above, and this last X comes over here, which is going to make this a stack of 4. So then this has to be redistributed, so that goes on the list too, saying that full stack at position 2. So I'm putting this debugging information, this trace information, to help keep track of what happens. So now here's my next situation. So the next one on the list to be handled is the stack at corresponds to square 4, which is right in here. And then I redistribute again. All these are from the perspective of the player who initiated this move, and that was X. So again, this top X is going to go down, and so forth. We continue on and show all the redistributions. Here, when I finally get to redistributing the pieces for X at position 2, when I take this top X and I go to move it down, I already have 4 there, so that piece automatically just goes off the board. I have the message greater than 4 pieces at location 5, returning the extra piece 4. In this case, it's X. And that prints out. And then lastly, I handle the redistribution at square 5. and then this is what I end up with at the end. To help myself, I also put a -1 in here so that I can exit the game. If I ever type a -1 instead of a valid number, I exit the game, and that's just helpful for me. So otherwise, I'd have to use Control-C. And there's just some leftovers from Windows, the pause command when I'm using dev C++ in Windows.